Now that we've looked at finding asymptotes algebraically, we want to apply those ideas to looking at sketching the graphs of rational functions. We can start off by finding our vertical asymptotes for the given function. To do that, we'll need to look at factoring both the numerator and denominator to see if anything will cancel. In this case, the numerator doesn't factor, but we can factor the denominator into x minus 6, x plus 6. Actually, let me make a change there. This should be x squared minus 49. So this should be x minus 7 and x plus 7. Sorry for the typo there. So nothing reduces or cancels. We have two values that will give us a 0 in the denominator, and those would be x equal to 7 or negative 7. So we can go ahead and plot those vertical asymptotes. To start giving some structure to what our graph will look like. Next, we can move on to talking about horizontal and oblique asymptotes. Again, what we're going to consider is our function approaching the dominant term or the leading term in the numerator and denominator. So this would be x to the fourth over x squared, which will reduce down to x squared. So we have no horizontal or oblique asymptotes, but we do know that the end behavior will match y equals x squared. From there, what we can do is start to fill in different points to see where our graph exists on the coordinate plane. 0 is always a nice point to choose, assuming it's not a restricted value. So we could start off by evaluating f of 0, which will come out to be negative 3 over 49. That's not a very nice point to plot, but we're just sketching. All that's really matters to us is that this is a little bit less than 0. So we can plot that first point. And then what we can do is plot a couple of points that get closer to our asymptotes. So in this case, we'll evaluate f of 5 and f of negative 5. In this case, both those values turn out to be negative 27. We're just sketching here, so really all that matters is that those points are somewhere much further negative than this first value we determined. So what that tells us is that our function is heading down and approaching those vertical asymptotes of negative 7 and 7 and heading down to negative infinity. From there, what we can do is go back to our vertical asymptotes that we found and identify the multiplicities for those zeros. In this case, we had x minus 7 and x plus 7 both set equal to 0 and both raised to the first power, so those would have multiplicities of 1 and 1. That's important because if we have an odd multiplicity, then we approach those vertical asymptotes in opposite directions. If we have even multiplicities for our asymptotes, then we approach in the same direction. What that tells us is that since as we're approaching x equals 7 from the left, our function is headed down to negative infinity. As we approach from the right, our function has to be headed up. So we're approaching that asymptote in opposite directions. Versus if we were approaching in the same direction, it would also be headed down to negative infinity. That means as we look to the left of x equals negative 7, our function has to be increasing towards infinity as we approach that asymptote. And then the next thing we can refer back to is that the end behavior is going to match x squared. That means as x approaches positive and negative infinity, our function needs to be increasing. So that tells us that at some point our function is going to curve back up and head off to positive infinity at both ends. So we're applying the behavior around the asymptote, knowing that we have an odd multiplicity, so telling us that our graph is curving in opposite directions as we approach from each side. We're using that end behavior of x squared, and we plotted a few test points in the middle to sketch out the general shape of this graph.